In this first problem, we're going to write an equation for the tangent to the curve at the given point, then sketch the curve and the tangent together. So we're using the definition in order to find the slope of the tangent line at a particular function or curve. And so we have y is equal to 4 minus x squared. So we will start by saying first that f of x is 4 minus x squared, and f of x plus h is 4 minus the quantity x plus h squared, but that is 4 minus x squared plus 2xh plus h squared. So that's the quantity in parentheses. So that gives us 4 minus x squared minus 2xh minus h squared. So therefore, we now get that the slope that we're looking for, m, is the limit as h approaches 0 of f of x plus h minus f of x all over h. So that's going to look like the limit as h approaches 0. F of x plus h is 4 minus x squared minus 2xh minus h squared. Then we're going to subtract off f of x. So f of x, we didn't simplify it here. Oh, it's just 4 minus x squared. So we're going to subtract off 4 minus x squared. And that entire quantity is divided by h. So we get that this is the limit as h approaches 0. So we're going to see that this 4 and this negative 4 are going to add to 0. And this negative x squared and this negative negative, which makes positive x squared, are going to add to 0. So that's going to give us minus 2xh minus h squared all over h squared. So we'll get the limit as h approaches 0. Let's factor out the h, and we get minus 2x minus h divided by h. And these two h's are going to divide out. So we get that the limit as h approaches 0, and we're going to get of minus 2x minus h, and this is negative 2x. So now we know what the limit of that particular function was. And so the question asks us, find an equation for the tangent curve to the given point. And so the point that we're going to use is the point 1, 3. So for us, our point, if x equals 1, then y is equal to 3. So when we graph this, we have a parabola. And so our parabola is 4 minus x squared. So when x is 0, y is 4. And when y is 0, x is 2, and negative 2. So we have a parabola, our upside down parabola, as such. Okay, so our point was 1, 3. So therefore the slope, m, is going to be minus 2 times our x value 1, which is minus 2. The equation of the tangent line is going to be y minus 3 is equal to negative 2 times x minus 1. So at the point 1, 3, which is roughly right here, we can draw our tangent line. As such. Okay. Next problem. Find the slope of the function graph at the given point. Then find the equation for the tangent to the graph there. So the point that we have here is the point x equals 3. And if x equals 3, then y is also equal to 3. So that will be our point. Okay, so now we need to find the slope. Again, this is going to be a little bit more difficult because this problem is a rational function. So now we're going to have g of x plus h minus g of x all over h. So we know that g of x is x over x minus 2, and g x plus h is x plus h divided by x plus h minus 2. So therefore m is going to be the limit as h approaches 0 of, we're going to start off with x plus h divided by x plus h minus 2 minus x divided by x plus h. And this whole thing, the whole thing is divided by h. So we can conveniently say that when we divide by h, it's the same as multiplying by 1 over h. So this is then the limit as h approaches 0 of 1 over h times the quantity x plus h divided by x plus h minus 2 minus x over x minus 2. Okay. So m is the limit as h approaches 0. I have 1 over h. Now I need a common denominator for what is on the right-hand side. Something's not right. Okay. This should be x minus 2. X plus h minus 2, x plus h over x plus h minus 2, and x over x minus 2. Now it is correct. So we're going to get x plus h times x minus 2 minus x plus h minus 2 times x. And that whole thing is now divided by the quantity x plus h minus 2 times x minus 2. Okay, now we need to simplify. It's going to take some algebra. So this is the limit as h approaches 0 of 1 over h. Then I'm going to get in the numerator x plus h, so x squared plus hx minus 2x minus 2h. Then I'm going to subtract off x squared plus xh minus 2x. And that entire quantity is divided by x plus h minus 2 times x minus 2. So m is equal to limit as h approaches 0 of 1 over h. So let's see what we can eliminate. So x squared is going to add to negative x squared. And then hx is going to add to negative hx. And negative 2x is going to add to a negative, which gives me a positive 2x. And so the only thing that survives in the numerator is minus 2h. And then this is divided by x plus h minus 2 times x minus 2. So let's just double check. We had x squared plus hx minus 2x minus 2h. And then we had a x squared and xh and a negative 2x. So x squared and negative x squared add to 0. Hx and a negative xh add to 0. And negative 2x and a positive to 2x add to 0. So that's what we get. So now we can divide out the h's, and we get that this is the limit as h approaches 0 of minus 2 or negative 2, which is what we have in the numerator. And then the denominator, we have x plus h minus 2 times x minus 2. So now as we take the limit, we get m is equal to negative 2 divided by the quantity. This h is going to go to 0. And so we're going to get over x minus 2 quantity squared. So now we know what the slope is at any given point. And so now we need to find an equation for the tangent to the graph. Okay, so our function, as we can see, our function has an asymptote at x equal to, a horizontal asymptote at x equal to 1 and a vertical asymptote at x equal to 2. So let's draw our function. Remember our function g of x look like x divided by x plus 2, x minus 2. So if we want to draw that, okay, we know it has an asymptote. So here's 1 and 2. It's going to have a vertical asymptote at x equal to -2, because we cannot put -2 in there. And the limit of this function actually will just go to 1 as x goes to infinity. So therefore, we're going to have a horizontal asymptote and if we put 0 in our function, when x is 0, we get -2. So our function is going to when we put 0 in, our function is 0. I apologize. And if we put 3 into our function, we already know that we get the point 3, 3. So there's the graph of our function. Okay, so now let's look at our tangent line. So if x is equal to 3, m is equal to -2 over -1 squared, which will be 1, so our slope is -2. So therefore, the equation of our tangent line is y minus 3 is equal to -2 times x minus 3. And our slope of our tangent line has a slope of -2. So our tangent line is going to look something like this. Okay. Next, we want to find the equation of all lines having slope equal to -1 that are tangent to this curve. So our function is y is equal to 1 over x minus 1. So what I would have you to do is, we know that our slope m is going to be the limit as h approaches 0 of f of x plus h minus f of x all over h. So that gives us, again, the limit as h approaches 0. So f of x plus h will be 1 divided by x plus h minus 1 over x minus 1, the entire quantity, all over h. And with some work, we get that m turns out to be -1 over x minus 1 squared. So that's going to be the derivative of our function. Okay, so now that we know that that's what our slope is, the question asks us to find all points where the slope is equal to -1. So therefore, we want to set this identically equal to -1. And that will equal -1 provided that x minus 1 quantity squared is equal to 1. So that says for us that x minus 1 so that says for us that x minus 1 can equal 1, or x minus 1 can equal -1, because both of these will have square equal to 1. So this one tells us that x is equal to 2, and this one tells us x is equal to 0. So those are the two places where the slope is equal to -1. That is, when x is equal to 2, the slope will be positive -1. And if x is equal to 0, the slope will be -1. So now that we know that, the only thing we have left to do is find the function values. So y is equal to 1 over x minus 1. So if x is equal to 2, y is equal to 1 over 2 minus 1, or 1. And the slope m is -1. So the tangent line there is going to be y minus 1 is equal to -1 times x minus 2. So this gives us y is equal to minus x. We're going to get plus 2, and we're going to add 1, so we're going to get 3. And then if x equals 0, y is not equal to -1. So if x equals 0, y is equal to -1. And our slope m is -1. So we get y minus a -1 is equal to minus x minus 1 times x minus 0. So this is y is equal to -x minus 1. So those are the two equations of the lines that we are looking for. Last question. What is the rate of change of the volume of a ball that looks like the volume is 4/3 pi r cubed with respect to the radius when the radius is r equals 2? So the rate of change is actually, again, the derivative. So we want to look at the rate of change of v. All right, so that's going to be v prime, or as we will call it, v prime of r. Is going to be the limit as h approaches 0 of v of r plus h minus v of r divided by h. So v of r is 4/3 pi r cubed, and v of r plus h is 4/3 pi r plus h quantity cubed. So this turns out to be 4/3 pi r cubed plus 3r squared h plus 3r h squared plus h cubed. So therefore, v prime at r is going to be the limit as h approaches 0 of 4/3 pi times r cubed plus 3r squared h plus 3r h squared plus h cubed minus 4/3 pi r cubed, because that's v of r, and we are going to divide by h. So therefore v prime of r, which is the rate of change, is the limit as h approaches 0. This is 4/3 pi r cubed here and 4/3 pi r cubed here. So they add to 0 because they're of opposite signs. And so we get 4/3 pi. Then we're going to get 3r squared h plus 3r h squared plus h cubed divided by h. Let's factor out an h. The limit as h approaches 0. So we have 4/3 pi, factor out an h, and that's going to give us 3r squared plus 3r times h plus h squared divided by h. So we get v prime of r is the limit as h approaches 0. So now this h and this h divide out. So we just get 4/3 pi times 3r squared plus 3r h plus h squared. And as h goes to 0, we end up with 4/3 pi times 3r squared. And finally, v prime of r is 4 pi r squared. Our original question is, what was the rate of change when r is equal to 2? So therefore, v prime at 2 is 4 pi. 2 squared is going to give me another 4. So my answer is 16 pi.